Okay, it can be inferred from the passage that which one of the following experimental results would suggest that bacteria detect changes in the concentration of an attractant by measuring its concentration in the front and back of the cell. So if you want to show that they measure it in the front and the back, then you'd want to show that they move when it's different at front and back somehow, right? That would be nice. Okay. And, all right, let's see what happens. A, when suddenly transferred from a medium in which the concentration of an attractant was uniformly low to one in which the concentration was uniformly high, the tendency of the bacteria to tumble and undergo random changes in direction increased. Well, if you go from uniformly low to uniformly high, and it's at the front and back, are you going to do anything differently? Wait, what are you going to do differently?
Oh, wait.
No, right? Because if it's front and back, then if it's uniformly low and then it's uniformly high, as far as you're concerned, you're testing things instantaneously. And you're like, well, the front and the back are exactly the same. So nothing is going to change in terms of more tumbling or less tumbling. We actually don't know what's going to happen. You don't, maybe you'll just stay there because there's nowhere to go, right? Okay. B, when suddenly transferred from a medium in which the concentration of attractant was uniformly low to one in which the concentration was uniformly high, the bacteria exhibited no change in the pattern of their motion. That would make sense if you check front and back because nothing has changed from your perspective. Right? If you're testing things over time, then things have changed. But if you're testing them from front to back, nothing's changed. And so you're like, okay, my behavior is not going to change either. Right? So this would suggest that they're testing it at the same time and they're looking at front and back. And front and back is the same because it says uniformly low to uniformly high. So I would keep this one open. C, when suddenly transferred from a medium in which the concentration of attractant was uniformly low to one in which the concentration was uniformly high, the bacteria movement was characterized by a complete absence of tumbling. What does this actually support? This is testing at one point, right? Because you're testing at one point it's low, you're testing at another point it's high, and so now you're like, okay, I don't want to tumble, I want to keep going in the same direction that I'm going. So this supports the theory that's supported by the passage, but not the theory that they're asking about in the question. Okay, D, when placed in a medium in which the concentration of an attractant in some areas are low and in others high, the bacteria exhibited an increased tendency to tumble in those areas where the concentration of the attractant was high.
No.
That doesn't make sense. If the attractant is high, you'd expect tumbling to drop, but here we really need, what is missing from D? There's something else that's missing. They're talking about the areas in which the concentration is high versus the areas in which the concentration is low. But what do we still don't even know with D? What are we trying to prove here? What's the question asking us to prove or support?
The bacteria looks in the front and back.
They look in the front and the back. So why doesn't D do that?
Because
telling you what. I'm sorry, go ahead.
Because we're trying to address uniform concentration. And
We are trying to address uniform concentration?
no,
Like, we have to or we need to? I mean, they're saying we're looking at ununiform. Yeah.
Because it's tumbling where the concentration is high.
Okay, so why does that...
Isn't it that it's like the concentration that we're in right now is it likes high concentration.
It likes
so
high,
It shouldn't
okay.
be going straight. It shouldn't be tumbling when it's.
Okay, it should be, but they're telling you, oh, now it's tumbling.
Right, shouldn't it not be?
So you're just saying, I don't think you should do that, bacteria.
Well,
Therefore, these studies are not helpful. Well, okay, but they're presenting these as like, this is what happened. And so,
yeah.
if this is what happened, if they started tumbling a lot,
Then it's just not measuring at all. If their original hypothesis hypothesis saying that when it's in high concentration, it should want to go straight and not tumble. If it is tumbling in high concentration, then according to their like initial parts of the passage.
I still feel like you're getting rid of this answer because you're like, I don't like the fact that they're tumbling in high concentration.
Well, I just feel like that was like their initial
Yeah.
hypothesis that shouldn't be like that's like one of their baselines. They're trying to understand why.
Okay, I guess my issue with this is like, what's at the front and what's at the back? Do we know? With this one? It just says we're in an area where the concentration's high. So it's like, okay, so
But
We
it
don't know
did
if
say
they're
it was
not
an
moving. We
attractant.
don't know if they're moving from a low area or not.
well, what does it say? When placed in a medium which concentration of the attractant in some areas is low and others is high, the bacteria exhibited an increased tendency to tumble in those areas where the concentrations of the attractant was high. So it's weird because it's going against the passage. The reason I still like want to deal with it is because it's saying like, if you had this experimental result, what could you infer from it? And if anything, this kind of like, you would have to accept this as true. You'd have to say, okay, well, why? Okay, if they're tumbling when it's high, does that tell me that they're looking at it in a snapshot in time, or does that tell me that they're looking at it from front to back? And I don't know that we know. I mean, this might actually strengthen the alternative hypothesis a little bit, because it's saying, look, when you go to areas in which there's higher concentration, they have an increased tendency to tumble. Well, that might be because the front end of the bacteria is facing towards low. Whereas if it's based on time, then as you go to high, in theory, the tumbling should actually go down. So I would say that B is better, but I don't think that D is like just wrong. Like I feel like if you're getting rid of it because you're like, oh, it contradicts passage out. It's like saying, well, what if this was your experimental result? What would you conclude from it? So we can't just be like, oh, this isn't true. We have to say, if it were true, does this help or hurt my explanation? And with D, I don't really know which way they're facing. So E, when suddenly transferred from a medium in which the concentration of attractant was uniformly low to one that was completely free of attractants, the bacteria exhibited a tendency to suppress tumbling and move in longer, straighter lines. Well, that's also weird because we would expect, I mean, this kind of goes back to what we were talking about D, we'd expect the tumbling to increase, especially if it's time. So maybe this weakens the time thing, but I don't know that it supports the front to back thing, because you're moving from one to the other. So I'm kind of like question mark with D, question mark with E, but B says uniformly high and there's no change. Yeah.
Well, didn't they also mention that when it's suddenly transferred? because
Oh,
it's
suddenly
transferred,
transferred. Yeah. So
they
it's
can't detect it.
yeah. So there's no, in theory, there's no awareness of you're just being like dropped.
Yeah.
Yeah. In that case, completely free of attractant, the bacteria exhibited a tendency to suppress tumbling, which is strange, but I don't know that that necessarily now supports the idea that they do it from front to back. It just makes things confusing.
Or I was gonna say, wouldn't it like completely eliminate it because of that? Because it's not, there's no information to support that E to be correct then.
When you say there's no information to support E, is that what you're saying?
Yeah.
See, that's where I get nervous, because I'm like, they're saying, which one of the following experimental results would suggest? So it's like you have to use the answer and then use it to support the idea that they do it from front to back. So I look at this as like, oh, I have to accept these results as true, and then say which one, if it were true, would do the most to support the front to back hypothesis.
Okay.
And I feel like D and E, if they are true, it's confusing because we're like, what? That doesn't seem like what would happen based on what we learned from the passage. But if that's true, at the very least, that would just undercut both theories. They'd just be like, okay, well, this is strange. I don't really know what to make of everything. But it doesn't necessarily support the idea that it's front to back. I just want to make sure that it's easy to get rid of it and say, oh, well, it's inconsistent with the passage. But since it's asking us which one would suggest or support this idea, it's like now I have to accept this is true and then try to figure out whether or not it does anything to support that. Yeah.
So then just like more of a logistic question for the test in general
Mm.
today, how likely is it for the question to have the correct answer not fall in line with the passage? Like, so you have to ask though, like,
If it's a strengthened question, well, there are things that you may feel like they're contradicting the passage, but when you look back at the text, you're like, oh, all we knew is that this was likely, or this was the tendency, but maybe it doesn't happen in this case or something, and then it's like it's an exception that starts to weaken the general claim, right? But yeah, in general, it's going to be consistent with the passage. Okay, so B makes sense because they don't change their motion because front back is equally high.